Oh guys, I'm nervous for this one. This is the Usefulness of Graphs, Unit 4, Lesson 2. So, functions begin with f of x equals, and equations begin with y equals. Okay, doesn't really matter, but just so you know, when two functions are set as equal to each other, the solution of both functions will be the point or points where they intersect on a graph. That's what we're doing today. We're taking two separate functions, setting them on opposite sides of an equal sign, and then when we solve it all, we'll know where they intersect. Okay? Steps to convert an equation into a function. If the steps are helpful for you, put this down in your notes. Steps are very helpful for me. I wish they had done this when I was in school. First, make both expressions in the equation in the format f of x equals an expression. Okay, so you're going to separate them into two separate expressions. Then you're going to set them equal to each other. Simplify by combining the equations and setting it equal to 0. Then you're going to put everything on one side of the equation. So you'll move everything over and put it equal to 0. Solve the quadratic equation to find the solution set. This is where things get sticky. They want us to factor again. I hate factoring so much. And finally, substitute the solutions for the x value into the original equations to find the corresponding y values to get your coordinates. I honestly don't know if I remember how to factor. It's been a while. Okay, so the first example is apparently unimportant because we have example 2. Create functions from the following equation to find the points of intersection and the solution set. Okay, so they're going to give you it in something that looks like this, and we're going to go through each step. Okay, if we the other steps are fine. We're gonna do this. I'm gonna figure out how to do factoring. I'm telling you right now, it is 9:34 a.m. We're gonna see how long this lesson takes me. First, we're gonna separate the equation into two functions, each representing one side of the equation. So this half is one function, this half is one function. So we have f of x is equal to x squared plus 10. Okay, I can do this. This part I can handle. And then g of x is equal to negative 8x minus 5. Now, throughout the lesson, I noticed sometimes they label both of these f of x. Sometimes one is f of x and one is g of x. It makes more sense to me to have them be labeled different letters, but in the end, it's all good. And then we need to remember that originally it was f of x is equal to g of x. This is just telling us this is what we started with. Okay. I can handle step 1. Step 1's okay. Step 2 is to combine both on one side and set it equal to 0. I love my typos in this. Equat. Equat is an amazing word. Forming a quadratic equation. Now, when you're doing this, this is the only thing you need to remember. It's math. It's always math. So we don't just randomly move stuff. We don't just boom it over here. You need to move it like a normal person. So if I want 5 to go over here, I need to add 5 to both sides. Okay, we're going to do that first, which means that we're going to have a positive 5 on this side. And if I want this 8x to go over here, this negative 8x, I need to add it to both sides. Okay, we're not just sticking it over here, we're actually doing the math steps to do it. So that's why negative 8x plus 5 became positive 8x plus 5 over here. Does that make sense? Okay, so now that you've got everything over here, there's terms we can combine. We can combine the 10 and the 5, the like terms, and then you need to put it in descending order. So we have x squared, then x, and then just our constants, which is 15. So that's what happened here. This I can handle. I can do step 2. Step 2 makes sense. Step 3, factor the equation to solve for x. Oh man, I was hoping we'd never see factors again. I was really hoping so. Alright, so we have this equation. We're going to see if I can remember how to do this because it's been a long time. I remember that we need two x's because when we distribute this out, we end up with x squared. Okay, so we have x and x. Everything's positive, so I remember we have the two positives. And then we need to figure out the variables here that can also give us this. So if we have 15, then the multiples of 15 are 1 and 15 and 3 and 5. Those are the only multiples. At least they're giving me an easy one to start with. And we know that if we add 3 and 5, we're going to end up with 8. So these have to be the two variables that are going in here. Okay, I'm kind of remembering this, kind of. Therefore, that means that our values for x, where it's going to intersect, remember we then put these equal to 0. I'm remembering. Okay, and then to solve for x, I'd have to subtract 3 from both sides, which would make x equal to -3. Okay, so that's where we got that value. And then for x plus 5 equals 0. If we're going to solve for x, we need to subtract 5 from both sides. And that's going to give us x equals -5. Okay, and that gives us this value. Oh, praise the Lord, I'm remembering this. So that gives us, these are the 2 points of intersection. We write it as a solution set, which has these weird little wavy brackets. So the solution set is -3, -5. Okay. This means the graphs will intersect when x equals -3 and x equals -5. And you will see that in a minute. We're going to see the graph. So this will make more sense. So don't worry about that yet. Okay, then you need to substitute the x value into the functions to solve to find the y coordinate. So we already know that we have -3 and -5 as our solution sets. So we're going to take these formulas, these equations that we got clear back at the beginning when we separated it into 2 separate equations. Do you remember that? And we're going to plug these values in to figure out our y coordinate. So what they did was they took -3 and put it into f. Okay, so we had f of -3 is equal to -3 squared, which gave us 9, plus 10. -3 plus 10, negative 9 plus 10, I can do this, is 19. So our first coordinate point is that -3 that we put in for x and 19 for y. All right, and then they're going to take -3 and put it in for g of x. So g of -3 is equal to -8 times -3, which is going to give us positive 24. Don't ask me where they got 25, Delulus. Okay, plus 10. So 24 plus 25, this should be 34. I mean, I know that. I know that should be 34. That's funny. Way to go, book. The coordinates should be the same for the second function if the solution set is correct. So we should end up with these same things when we plug in these numbers into g. Okay, so they did f. Oh, that's why, because they did it for f. I see. We were still working on f. I did it a different way than they did. Okay, so they did f again, which would be f of -5 is -5 squared. 5 times -5 is positive 25 plus 10. Okay, so this is actually right. They were doing f and f. Now they're going to do it g and g, and you see that you end up with the exact same coordinate points. So we solved it correctly. This is just all checking our work. That's all that this is. Okay. Now you can see here that when x equals, we figured out it was -3 and -5. When here's the -5 and there's our intersection point, okay, where the 2 lines cross. I'm going to blow this up because the blue line is really hard to see here. But you can see right here the blue and orange lines cross at -3, x equals -3. And here the blue line crosses at x equals -5. Sorry, I did those backwards. Okay. And then if we figured out where the y-intercepts are, because sometimes you need to know that information too. All right. That's what we did on this last slide where we checked to make sure that our answers actually worked. Okay. Now here's tables of values for these two. Now the way you would figure out these numbers is to take all these different x values. They use -5, -4, -3, 0, 3, and 4. And you would plug them into these equations again and solve for y. And that would give you these y values, okay? And what this does is it allows us to look and see where they intersect. You can see here this is for the orange graph, and this is for the blue graph. You can see they both have -5, -35, and they both have, they both have -3 and 19. So those are our points of intersection. That's how you find that on a chart, okay? So I showed you how to do it with an equation. You can easily do it on a graph. You can look and see on a graph. And on a chart, you just look for the coordinate pairs that match exactly. Okay? Here's practice question number 1. This is at the end of the lesson, so you'll want to solve this and write your answer down and save it for when you get to that point. It says the tables represent the functions in the equation f of x equals g of x. What is the solution set? So pause it, figure it out, come back. So the way we figure out on a table where the points of intersections are or where the solution is to find the points that match. -1 and -12 and -1 and -8 don't match, so it's not that. 1, -2, 1, -2 do match, so there's our first set. Okay, we don't have a 0 over here. 3, 4 also match. Okay, we don't have a 2 over here. We don't have a 5 and we don't have a 6. So there's our 2 points of intersection. So the way you write your solution set is the only value that matters is x. X is the winner, okay? So we need 1 and 3, and you write it in ascending order. So it's going to be 1 and 3. It's never going to be 3, 1. You write it in ascending order. All right? That's how you do practice question number 1. Here is a check-in. How can you find the y-coordinates after getting the solution set of the functions? So when you have the solution set, like this one was 1, 3, how do you find the y-coordinates? You substitute the solutions for the x value into the original equations to find the corresponding y-coordinates. That's what we did here. Nope, this is where we split it apart. That's what we did here. We took our values, the -3 and the -5, and we plugged them back into here. Okay, that's how you find your y-coordinates. Here's example number 3. Create functions from the following equation to find the points of intersection and the solution set. So it wants both the points of intersection and the solution set this time. And here's our formula. We'll go through this step by step together. So first you separate it into 2 functions. This is function 1, and we're going to call it f of x. This is function 2. We'll call it g of x, and we have to remind ourselves that the original problem is f of x is equal to g of x. Okay? The second step is to combine both functions on one side and set it equal to 0, forming a quadratic equation. Okay? So we start with f of x, and then we want g of x to be there too. Okay? So we're going to do x squared minus 5x plus 7 is equal to g of x, which is 2x plus 1. Okay, that's this one right here. We need to move all this over. So we're going to subtract 1 from both sides. Okay, so we have x squared minus 5x. 7 minus 1 is 6 equals 2x. And we want 0 on this side, so we still got to subtract 2x from both sides. Okay, 2x. And that's going to give us x squared minus 7x. They say plus, oh, it is a plus 6. That was my bad. Plus 6 equals 0. That's how we came up with this formula right here. All right. I moved that formula right here for our reference. So third, solve the quadratic equation by factoring to solve. Okay, I managed to factor last time. Let's see if I can factor this time. Oh, it's a little scary. All right, I believe in myself. I can do this. Okay, here's our formula. We have x squared minus 7x plus 6 equals 0. So we need to find the factors of 6 that are going to give us that. So the factors of 6 are 1 and 6 and 2 and 3. Okay, so 1 and 6 will get us to 7 if they're both negative. So that means we should have x minus 1 and x minus 6. Now, when you're doing these factories, oh my gosh, it doesn't matter which number goes first because we're multiplying. So it could be 6 here and 1 here. It's fine. It doesn't matter. Okay. But this will work because we have x squared, 6x, 1x, which will give us 7, and then this will give us a positive 6. So I know this worked. So that means our values are going to be x is equal to positive 1 and x is equal to positive 6. And I know that because if I go x minus 1 equals 0 and add 1 to both sides, then I'm going to end up with x is equal to 1. Okay, so it's going to work for 6 too. So here's our 2 solutions. and our solution set. Our solution set is 1 and 6. Okay, I did it right. Go me! So substitute the solutions for x in the equation to find the corresponding y coordinates to get the points of intersection. Okay, so we're going back to these formulas right here. Special, fancy, glitter. And we're going to substitute these values in. Okay, and I believe, guess who had the problem written wrong so she couldn't get the right answer? Just me. Okay, the parentheses should be right here, and the parentheses should be right here. Let's try again. So we have 1 squared. Negative 5 times 1 is negative 5. Plus 7 gives us, and now we do the exponents, 1. Negative 5 plus 7 is positive 2. So that gives us 3. So our first coordinate pair is 1, 3. Okay. Oh, I don't need to erase it. Now we have 6 squared, parentheses first, negative 5 times 6 is negative 30, plus 7, 6 squared is 36, minus 23, which gives us 13. So our second coordinate point is 6, 13. Now we need to solve for g of x, which I did not put on this screen because I'm a genius. So let's go look at the formula for g of x. G of x is 2x plus 1. So we have g of 1 is equal to 2x plus 1. This is just to verify that we got the correct coordinate points because they should be the same. So this gives us 2 plus 1, which gives us 3. And look at that, we have 1, 3 again. So we did that right. Now we have g of 6 is equal to 2 times 6. I can write plus 1, which gives us 12, plus 1, which gives us 13. So our second coordinate set is 6, 13. So that worked. Okay, so here we see our coordinate points. You can see they're here. Oh, look, they cross. And here, oh, look, they cross. They intersect. We did it right. Do, 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 do. I'm managing to factor. That's really scary. Check in. If the solution set for a function is negative 6, 5, what does that mean? Do you know? It means the graphs will intersect when the x coordinates are negative 6 and 5. Your turn. Boom, boom, boom. Create functions from the following equation and write the corresponding quadratic equation, but do not solve. So all it wants is the functions and the quadratic equation. So the first 2 steps. You can do this. Pause the video, do it, come back. Functions are really easy. You're just going to separate right here at the equal sign, make one f of x, make the other g of x. And the quadratic equation is to set them equal to each other and then move all this to the other side. So it becomes negative x and negative 4. Okay. And make it equal to 0. But here's the thing. We can combine terms. Okay. So that would leave us with x squared. 2x minus x is just 1x, and positive 1 minus 4 is a negative 3. So there is your quadratic equation. Here's question 2 that's all you. Oh, and by the way, who in the world would eat this nastiness? Look at it. It's like covered in crud. Now, if this was cheesecake and this was powdered sugar, okay, but it's not. It's like cheese, like savory cheese. Blah. Okay. Create functions from the following equation to find the points of intersection and the solution set. Okay, so I want you to do everything this time. Pause the video, figure it out, come back. Okay, so the solution set is negative 1, negative 3, and the points of intersection are negative 1, negative 3, and negative 3, negative 7. Okay, if you need me to do this one for you or with you, show you all the steps, comment and I'll make another video. Here's practice question number 2 at the very end of your lesson, so write this answer down. The functions g of x and f of x are graphed. What is the larger solution in the solution set of f of x equals g of x? Pause it, figure it out, come back. So the solution set is the one that's written in the wavy brackets, okay? And for this one, there would be two numbers, and it wants to know what the larger solution is. The only number that matters in these coordinate points is the x one. So we're not going to worry about the lower number because it wants the larger solution. It's this 4. The answer is 4, the bigger number. Here's a quick check question at the end of the lesson. I won't give you this answer, but I'll tell you how to find it. To show how to solve the equation, write two functions and find their intersection points. What two functions can be used to solve the following equation, and what is their solution set? So the two functions are just separated right there. One is f of x, one is g of x. And then you would go through all of your 4 steps and figure out what the solution set is. Okay, you only have to go as far as the solution set. Okay? Quick check question number 2. The graph of g of x and f of x is shown. What is the smaller solution to g of x is equal to f of x? It doesn't matter if it's g of x first, because it's equal. They can be in whatever order they want, so don't get tripped up by that. The solution set is the thing that's written in the wavy brackets. In this case, there would be two numbers, and they want to know the smaller one, so this one is out. There is only one number in the solution set that matters, and that is x. So find the smaller x value and select it. Solutions to equations. In the graph of an equation, the solution is the point where the graph crosses the x-axis. Okay? So now we're talking about, instead of an intersection, if we have just one line, the solution is where it crosses the x-axis. Some graphs may have more than one solution. F of x is the same as the y coordinate. We've done this forever. F of x is equal to y. Okay? They're the same thing. So setting the equation equal to 0 allows you to find the corresponding y coordinates for given x coordinates. That's why we've been setting them to 0. Some equations may have no solutions because the graph never crosses the x-axis. So if you have a graph that's like somewhere up here, there's no solutions because it never crosses this line. When you find a solution, substitute it back into the equation and solve to determine whether it creates a true mathematical statement. So check your work. Check in when you rewrite an equation that has a constant on one side. So if you have like y, sorry, I shouldn't use letters. We'll use real numbers. If I have 2x equals 1, okay, if we have a formula like that. And then, so it has this constant on one side, and then graph it. How can you identify the solution to the equation on the graph? So again, in this case, the solution is where it crosses the x-axis. Okay? So how can we find that? The solution will be the point where the graph intersects the x-axis. So the first thing you need to do is move this over and then figure out where it crosses the x-axis. Okay? Example 1. Draw a graph to find the solution to negative 2x plus 10 equals 3. Note the constant 3 on the right side of the equation, right here. To solve this equation and graph it, the equation has to equal 0. Therefore, the 3 needs to be moved to the left side of the equation. So if you have a formula like this, the first thing you need to do is make it equal to 0. You got to move this sucker over. Okay? So rewrite the equation so it is equal to 0 by moving the 3 to the left side of the equation. Do not just leave off the constant. It is a part of the equation. Just relocate it by subtracting it from both sides of the equation. So we took that 3 and subtracted it, and now we have this equation. Here's the original equation. Here's the new equation. Select 3 or 4 points to graph by substituting the values for x. For this example, use 0, 1, 2, and 3 to graph. Okay? So what you would do is you're going to take your formula right here, and we're going to say x is equal to 0, negative 2, times 0, plus 7 equals 0. Okay? Negative 2 times 0 is 0. Plus 7, our y coordinate, we're setting it equal to y, I apologize, is equal to 7. So our first coordinate, when x equals 0, y equals 7, okay? You would do that for every point for your 1, 2, and 3 too, as well. Sorry, 1, 2, and 3 as well. Does that make sense? So here you can see we have our 0, 7. Then you'd get your other points, you'd plot them You draw your line, okay? You can also go to GeoGebra.com and just enter y equals negative 2x plus 7 and let it do the work for you. Yay! Okay, this is our original problem. See, we're not equal to 0 anymore. Identify the solution. Because the graph crosses the x-axis at 3.50, see, this is where it's crossing the x-axis, so that's our solution. The solution to this graph is 3.5. Check the solution by substituting it into the original equation, okay? So we're going to go negative 2 times 3.5 plus 10 should equal 3. Okay? Negative 2 times 3.5, I am totally busting my calculator out for that. 2 times 3.5 gives us a negative 7. Negative 7 plus 10 does equal 3. Oh my goodness, so it worked. We were right. We did it right. Imagine that. In the case of an equation in the form ax plus b equals 0, where b is the constant, the b represents where the graph intersects with the y-axis. We've known this forever. This is also called mx plus b. This is the y-intercept. Okay? Example 2. Draw a graph to find the solution to 3x plus 6 equals 0. Now, you can go through and do all the table, or you can go to GeoGebra.com and go y equals 3x plus 6 and let it do the work for you. Because the equation is already set equal to 0, select 3 or 4 points to graph by substituting the values for x. For this example, use negative 1, 0, 1, and 2 to graph. So in this case, I would go y equals, we'll do negative 1, 3 times negative 1 plus 6. This gives us negative 3 plus 6 gives us positive 3. So our first coordinate pair is negative 1, positive 3. You would do that for each of these x values. And look at here, negative 1, positive 3. Okay, this is what our graph looks like. Identify the solution. Well, where does it cross the x-axis? Right there at negative 2, 0. So that means the solution is negative 2. And you check the solution by substituting back into the original equation. Here's our original equation. So we have 3 times negative 2 plus 6 should equal 0. And look, 3 times negative 2 is negative 6. Negative 6 plus 6 does in fact equal 0. So we found the correct solution. Here's a check-in. Where is Tall Man? Where is Tall Man? I forgot that I put songs in. Why is it necessary to rewrite the equation so that the constant is no longer isolated on one side of the equation? Why can't we leave it as 2x equals 1? Why can't we leave it like that? Rewriting the equation allows you to find y coordinates for any given x value. Without rewriting it, you are limited to the x values that make the math statement true. You cannot find y when the constant is by itself on one side of the equation. Example 3. Solve the following quadratic equation with a constant on one side using a graph. X squared equals 3x minus 3x equals 10. So first rewrite the equation so it is equal to 0. Move the 10 to the same side as the variable by subtracting that value from both sides. So you would just subtract 10 here. So it would be x squared minus 3x minus 10 equals 0. That's our new formula. You can then either make a graph or go to GeoGebra.com and enter y equals x squared minus 3x minus 10 and let it do the work for you. Okay. Next, you're going to create a table of coordinates to graph. Use 3 to 5 values. They use negative 2, 0, 2, 4, and 6. To find this value, you would take your new formula. You would go negative 2, squared minus 3 times negative 2 minus 10 equals y. I did that backwards. So this is negative 4. This is negative 6. Negative 4 minus negative 6 is negative 10 minus negative 10. So our y should be negative 20. So with negative, it equals 0, so this must have been a positive 10. Oh, yep, negative 10 and negative 10. Yep. Anyway, here's your coordinates. Plot the points on the graph to locate the solutions. The graph may reveal an additional answer not in the table. And look at that, there are two. The table only showed us one x-intercept when x equals 0. I mean, when x equals 0, we have negative 10, which we can see. Oh no, that's a y-intercept. I can do this, guys. I really can. Right here, when x is negative 2, y is 0. There's one x-intercept. But because we didn't happen to pick 5 to put on our table, we didn't have the second one. And we can see here there is a second intercept. So graphing it is necessary for that reason. Because the graph crosses the x-axis at negative 2, 0, and 5, 0, the solutions to this equation are negative 2 and 5. Check the solutions by substituting them into the original equation. So you would go negative 2 squared minus 3 times negative 2 minus 10 should equal 0. Negative 2 squared is a positive 4. Negative 3 times negative 2 is a positive 6. 4 plus 6 minus 10 does in fact equal 0. Okay. And then you would check it for 5. So 5 squared minus 3 times 5 minus 10 should equal 0. 5 times 5 is 25. Minus 15 would give us 10. Minus 10 does in fact equal 0. Here's example number 4. Solve the following equation by graphing. X squared minus x minus 6 equals 0. Factor the equation to find the values. So the first thing we need to do is factor this out. We need to find the factors of 6 that are going to give us negative 1. So 6 factors into 1 and 6, and 2 and 3. And if we take 2 and subtract 3, we'll get negative 1. So it factors into x plus 2 and x minus 3, I believe. Because x squared, 3x, 2x, nope. So let's make this one negative 2. Let's make this one a positive 3 and try that. So x squared, 3x, 2x. Let's see what they did. See, factoring is tough for me. Negative 3, positive 2. Oh, I just needed to put the 3 over here. Sure. Okay. So anyway, our values are x equals 3 and x equals negative 2. Then you're going to create a table of coordinates to graph. Use 3 to 5 values. They did negative 2, 0, positive 2, and 4. So we have negative 2. We're using the formula at the top. Squared minus negative 2 minus 6 is equal to our y value. Negative 2 times negative 2 is positive 4. This becomes a positive 2, negative and a negative. Minus 6 equals y. 4 plus 2 is 6, minus 6 equals y. So this y coordinate will be a 0. Let's do the next one. We'll do 4. 4 squared minus 4 minus 6 equals y. 4 squared is, 4 times 4 is 6. No, 4 times, I don't trust myself. Is it 16? I'm so tired. 4 times 4, it's, yeah, that I thought it was 64. I'm doing really well. Minus 4 minus 6. So 16 to minus 4 is 12. Minus 6 gives us another 6, okay? You would do that for the whole table. You get these values. Plot the points on a graph to locate the solutions. So we say we have 2 x-intercepts, one here and one here. And that means the solutions are negative 2 and 3. And then you check the solutions by substituting them into the original equation. So we have negative 2 squared minus negative 2 minus 6 should equal 0. This becomes 4. This becomes a positive 2. So 6 minus 6 does in fact equal 0. So that one worked. Let's check for our second value, which is 3. We have 3 squared minus 3 minus 6 equals 0. 3 squared is 9. Minus 3 is 6. Minus 6 does in fact equal 0. So here's example 5. Solve the following equation by graphing 2x squared plus 1 equals 0. Create a table of coordinates to graph. Use 3 to 5 values. There's the values they gave us. We'll go ahead and solve for -2. So we have 2 times -2 squared plus 1 is equal to our y value. So first parentheses, -2 times -2 is +4. So 2 times 4 plus 1 is equal to y. 2 times 4 is 8 plus 1 is 9. You would do that for the whole table. There's your values. Plot the points on a graph. There you go. The equation has no solution because it never crosses the x-axis at any point. It never will. Solve. Oh, we already did that. I don't know why that's there again. Haha. Here's an interactive question. In an equation with a constant on one side, it is necessary to rewrite the equation so that it is equal to 0. When the equation is graphed, the solution is the point where the graph crosses the x-axis. To check the solutions, substitute them in the original equation. Okay, this is all you. Question 1. I have 2 dogs fighting over my love and affection. What solution does the graph show to the equation 3x squared plus 6 equals 9? Okay, this is a speed round. Boo 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 boo. What's the solution? Boo 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 boo. -1 and 1. I hope you got that. It's just where it crosses the x-axis, and only the x values matter. Question 2. The graph for the equation -x plus 15 equals 10 passes through the following coordinates: 2, 3, 3, 2, 4, 1, 5, 0, and 6, -1. Answer the following. What type of function is it? How would you rewrite the equation to graph and find the solution? What is the solution to the equation? Pause the video, answer all 3 questions, and come back. Oh. Hey, it got all screwed up. So this is a linear function because it doesn't have any x squareds or anything weird in it. To rewrite it as a correct equation to graph it, it would be -x plus 5, because you're going to subtract 10 from each side equals 0. And then the solution to the equation is... That's not it. I don't know why I don't have the solution on here. I guess we'll go ahead and figure it out together, won't we? The solution is simply where it crosses the x-axis, which is going to be right there. 5, 0. Okay. If you graph it, there may be another x-axis. I mean, another coordinate where it crosses. So, yeah. Question 2. Look at this. Why is everything so screwed up? It was doing so well. The graph for the equation -x plus 15 equals 10 passes through the following coordinates. Didn't we just do this? Oh no, that's the answers. Okay. Whatever. Practice question number 3. Create a function graph to answer the question. What are the solutions to the equation? Blah. Enter the smaller value first. So go answer this. Come back. Alright, so first you got to write this as x squared minus 5x. We got to move that -4 to the other side so it becomes +4 equals 0. Okay? There's 2 ways to do this. The first way is to, you know, make your table of values and all of that garbage. But why work smarter when you, why work harder when you can work smarter? So we're going to go with y equals x squared minus 5x plus 4. Now we're going to head over to GeoGebra. Now why am I telling you to go to GeoGebra when the lesson doesn't? There's a couple of reasons. First of all, in the real world, when you have an employer and they need you to do something like this, although I don't know what job would require that, but let's just say that you have a job that requires that. Do you really think that they're going to appreciate you taking the time to do all of this by hand? Because the answer is no. They want the answer fast. They want the answer now. Okay? So it's going to be much more time effective and cost effective for you to just go ahead and go to GeoGebra and do it this way. And the second reason is you know how to create the table and how to find all the solutions. You have to do it for other problems, so why keep doing it over and over and over? There you go. There's your solutions, 1 and 4. All right, your answers are 1 and 4. Okay, here's example number 1. Find the solution to the following equation with algebraic expression on both sides by graphing. So first, this is kind of the whole lesson altogether, so we're going back to what we learned first. You're going to separate this function into two equations by splitting right there, making one f of x and the other, they did f of x again, but I would do g of x because why make it harder than it has to be? The second is to graph each function separately by creating a table of values or using a graphing calculator. See, it tells you right there in the lesson to do it. So why would you create a table of values? That's just like the stupidest thing ever. So you go to geogebra.com, you go y equals x plus 2, and then on another line, you do y equals negative x plus 3, and look at that. It's going to give you this exact graph that's over here, okay? So line 1, which I'm guessing is this blue one, represents, no, actually, it's the orange because it's positive. Line 1 represents f of x equals x plus 2, and you can tell that because there's the y-intercept at 2. Line 2 represents f of x is negative 3. Both lines intersect at point 0.5, 2.5, which is right here, okay? Therefore, the solution to this equation is when the x value is 0.5. Okay, so solution here is 0.5 because we're two lines means we're looking for the intersection. Check the solution by substituting 0.5 for x in the original equation. So that means we have 0.5 plus 2 should be equal to negative 0.5 plus 3. I don't think that's possible for that to work because this is going to give us 2.5. Oh no, it works. It's 2.5. I just don't have a math brain. Okay, example 2. Find the solution to the following equation with algebraic expression on both sides by graphing. So first, separate it into two functions right there, f of x and g of x. Graph each function separately by creating a table of values or by using a graphing calculator. Use your brain, people. You end up with this graph. And to find the solution, line 1 represents 2x plus 3 and line 2 represents 2x minus 2. The two lines are parallel to each other and they will never intersect, so this equation has no solutions. What does it mean if the graphs of both functions are parallel? We just did that. You should know this. The equation has no solution because the graphs will never intersect. Here's example 3. Find the solution to the following equation with algebraic expressions on both sides by graphing 2x squared minus 2 and x equals x plus 1. So separate it by splitting right there. Get f of x and g of x. Graph each function separately by using a graphing calculator. Gives you that graph. Find the solution. Hey, look. They intersect right there and right there. And the only numbers that matter are the x values. So that means our solutions are negative 1 and 1.5. And then you're going to check the solution by putting these numbers into here. So 2 times negative 1 squared minus 2 equals negative 1 plus 1. Okay? Negative 1 times negative 1 is positive 1. 2 times 1 is 2. 2 minus 2 is equal to negative 1 plus 1. And guess what? That's 0 and 0. So that first one is a go. That is a Jolly Roger win. The second value is 1.5. So 2 times 1.5 squared minus 2 equals 1.5 plus 1. Calculator time, because I don't like to try. 1.5 times 1.5 is 2.25 times 2. So this gives us 4.5 minus 2 equals 2.5. 4.5 minus 2 is 2.5. So guess what? That one is another win. Winner, winner, chicken dinner. Check in. Why is it best to separate the equation into two functions to find the solution? Because I want this lesson to be over. Having two functions allows you to have two graphs and helps you see where they intersect or if they intersect, and to determine the solution based on the representations on the graph. Oh, aren't you just a smart little boy? Question number 1, all you. Based on the graph, what is the solution to the equation? 2x plus 3 equals 4x plus 1. What is the point of intersection? So the solution is going to be where they intersect, which is right there at x equals 1. And the point of intersection is 1, 5. I'm so smart. I'm sorry. I should have let you do that on your own. Question number 2. Using the information in question 1, what are the functions created from the equation, and what type of functions are they? Okay. So pause it, figure it out, come back. Well, the functions are, you're going to split this formula right there. Here's f of x, here's g of x, and the functions are both linear. I'm so smart. I wish all the questions were like this. I swear they build up your confidence and then they're like, stupid, slap. Practice question 4. What value of k would make a solution to the equation 3x minus 5 equals negative 3x plus 7? Pause it, figure it out, come back. Well, we have two formulas here, so we're looking for an intersection. So we have 0, negative 5. That doesn't work. They're not the same. 1, negative 2. Nope. 2, 1. That could be it right there. Okay. 3, 4 doesn't have a match. 4, 7 doesn't have a match. So therefore, the answer has to be 2. Question number 5. What is the solution of 2x minus 7 equals x over 2 minus 1? Pause the video, figure it out, come back. This should be an equals. I apologize. It should be x equals what? The solution to the equation is where they intersect right there, and the only number that matters is x, so it's 4. Quick check question 3. Create a function graph to answer the question. Use the function graph to solve the solutions to the equation x squared equals 2x equals 3. So in order to do this, first you're going to move this 3 over here to make it equal to 0. Then you're going to take this new formula and make it equal to y. So it's y equals x squared plus 2x. We moved that 3, so now it's a negative 3. You're going to go to geogebra.com and graph this. Then you're going to see where it crosses the x-intercept and find your answer. Quick check question number 4. Use the function graphs to solve the equation 2x plus 3 equals 3x plus 4. We have 2 here, so we're looking for an intersection. So all you're going to do is blow this up really big. Look at where they cross, which is right there. And you're going to find the value. Which letter matters? There's only one letter that's mattered this whole lesson. Is it x or y? You're going to find that and select that as your answer. Quick check question number 5. What value of k in the table will be the solution to the equation negative x squared plus 5x equals negative x plus 5? And I did not put the right information in here. I apologize for that. So this is the negative x squared plus 5x. This is the negative x plus 5. So what you're going to do is go through the charts, find the ones that match, and then figure out your number. Did you know that Stray Kids has a song named Cheese? You should go listen to it.